მოგესალმებით, ქალბატონო.
Welcome, everybody, ladies and gentlemen. Now, just would like to remind you, I am Georgi Abulashvili from the Energy Efficiency Center. But before we start the content of our agenda, let me remind you some technical issues. Down on the screen, you have the sign of the globe. And when you go into that globe, you can select the language which you desire to hear. So English and Georgian. At the same time, I would like to ask you that when you select the language, please just mute the other languages and you will be able to listen the interpretation. And I would like to thank from the very beginning to our interpreters because we are going to keep them busy today. So, you can select either English or Georgian. Of course, together with you, now I start speaking in Georgian, and then our participants, those who are not the Georgian speaking, they just stay in English channel. Yeah. Now I'm already in a Georgian channel together with you, and another organizational the type of the statement. Of course, it is not our first meeting. However, I would like to remind you about the rules because you know that if you really need to make your comments or questions, there is very good option. You can raise your hand and put the question. And of course, you also can write in the chat. You already got the message that this meeting is being recorded, but it does not mean at all that you have to control your behavior or your words. I don't know. Just keep in mind that we are recording this meeting. And if you have any objection, you have to let us know. If you have the technical possibility from the beginning, please keep your video on in order to make so-called the family photo, at least in distance, and we will make the good screenshot. Today we have the session about the energy efficiency and the cleaner production training. And we have, widely known international experts, the Sergey and Dimitro. They are going to help us. Of course, they share their own knowledge and experience. Together with us, we have here the national experts, technical experts, Mr. Nodar Kevhishvili and Kote Barjadze. And we all, of course, try to get as much information as possible from them. Not only information, but the knowledge and the experience. And I do hope that we would be able to apply them in a successful manner later on. About up to 5 o'clock, we will be working today. We start with our homeworks. We will listen to the homework, some sort of assessment evaluation based on the individual consultations. And we had this possibility during two previous meetings. And then we start speaking about the mass and balance issues and follow the agenda. In order not to bother each other or one another, of course, we are going to have some small breaks, so-called the coffee break, and we could, of course, offer you coffee, but we have no possibility. We just can offer you break for coffee. Today and tomorrow, we have a very interesting meetings, I do hope, but let's speak about tomorrow later on. So it's all from my side. If you have any question, please feel free. If not, I would like to give the floor to Mr. Sergey. And as it is said in English, last but not least, technically we are provided by Roxana Bea, and she has a wonderful smile in the screen now, and we are very thankful to her. And now the floor is given to Sergey, please.
Thank you. Спасибо большое. Very
Very happy to meet you, dear friends, and we are becoming gradually close friends. And with many of you, we met a few days ago, and I would be very happy to see your faces. That it's easier for me to maintain eye contact, and I think today and tomorrow we're going to speak about very practical things that could be useful, and for those who want to become an energy author, an auditor on resource efficiency, I think the content of the session would be very useful. So strongly encourage you to stay both days, listen to myself and to my colleagues, ask questions, and participate actively. And actually, it might be boring. We all want to meet in person. I'll try to be shorter than previous time, and don't hesitate to ask me. It's very good sign when we have some discussion. So I know that the work is going on, but it's not easy. I had the possibility to go through your reports, and I know that we all face challenges. It's not so easy to visit our company, but this is not surprise for myself. I knew that we would reach certain point when we would start working on details, doing calculations, and then we need extra motivation, extra capacity to do this. I'll try to help you, and my colleague will also from EC Georgia. My colleague Dmitry will also try to help you, and of course encourage you. It's I think it's an interesting journey. My teacher, when I studied cleaner production for now, I think it's almost 20 years ago at University of Amsterdam, he used to tell me that this is not a short story, it's a journey. You go there and you will never come back because you will be excited to find opportunities. Because when we started to learn environmental science, we were thinking always that environment costs money. Environmental protection is costly. With this methodology, we can save money and save the environment. I think this is a very noble task that could be done for the satisfaction of business strategies. So I think this session will touch upon very practical and useful aspects for those who want to continue this work in future. But let me first very quickly review what we have been doing last time in April. And for that, I will try to upload my presentation. Few slides. Could you see the slides? No. Yeah.
Yeah.
Yeah, it's good. I just show you a few slides that we have seen before, and we've been speaking last time about inventory of waste sources. You know that our methodology is about structural look at our production processes. We do things step by step. We do things systematically. We try to first to observe a problem, try to find what is the reason for the problem, what is the cause for the problem, and only after that we would address any solution to this problem. And of course, nobody tells us where the problem. And many companies, your companies, my companies, they see them and feel happy. They think that they are effective, they are efficient, they don't lose. So it's not easy to find anything, and they don't measure their consumption. So we use some instruments to unveil areas of opportunities or problems at the companies where they lose water, where they use too much energy, where they lose their raw materials. And for that, we've been speaking last time that we split the process in some most important parts, try to quantify flows that come in and come out at each main step of production process. We go to and review the production itself, try to oversee the production with a pair of fresh eyes. And then we would probably notice something that our companies never notice already, because they are used to current. They feel that things are normal. But we have fresh eyes. We notice some things that are striking. But this is not enough. We would also need to collect production data, statistics, records, do measurements to see how the energy performance, production performance, actually is done. And then based on that, we locate the problem, and we try to find solution to this problem. And a very important tool is to make a ad hoc, useful, informal breakdown of technology process, and to quantify all the flows, what come in and what come out, and try to see where we make losses, where we use energy, where we use water, where we experience rejects. All this information then helps you. It's kind of a map. It gives you exact location where should we look for opportunities, where we should look for an improvement. This we have discussed last time. And in ideal world, we will collect a lot of data. We will be able to prepare nice graphs. We will be prepared. We will be able to analyze consumption of water, consumption of energy, consumption of raw materials at each specific place. But this is not true. This is not true in Norway. This is not true in Ukraine, and it's not true in Georgia. We have to do assumptions, and sometimes it's easy, sometimes it's not so easy, and it's very much has to do with our qualification, with our competence to make correct assumptions, to make theoretical estimates, to make some calculations that would give us maybe a little quite not so quantitative information, but at least give us qualitatively an answer where the problem is. Assumptions are very helpful. And it's an example of such an assumption, which actually could also be relevant for some of your companies, is for example, use a recipe. You, for example, have a cheese making company in our program. We know how much cheese is produced from a certain quantity of milk. and we know how much cheese we sell. And then we compare the recipe with the accounts from our sales department, and we will find a difference, possibly. And if it's different, we start questioning why the actual situation differs from the recipe. That's a very easy and simple, maybe a simplistic example of what could be done, how to overcome a problem of not having enough data. And we have also discussed last time that we need to establish certain indicators that that we would use to measure our performance. We've been talking last time and last week, and many of you reported that your companies think that they are effective or efficient. They don't lose energy much. This is their belief. If it's correct or not, we don't know. But it's an important task for us as professional people, as people that come and make a professional review, is to assess whether the company's belief is true or not. Whether it's a misjudgment or it's based on certain established routines and notions. And then we would probably find possible to identify certain, maybe few, maybe more than few, maybe simple, maybe more sophisticated indicators, and to measure company's performance. In the best case, we would be able to find, for example, a benchmark, how much energy is used per one, for example, egg at Tileti factory, poultry factory, in best case. But could be that we will not find a benchmark that would allow us to compare with the best practice. Then we just take historic statistics and to see how the energy used, for example, per one egg produced at Tileti varies. We try to calculate this data and we will see variations, and then we could define our self-target line, and everything that is above target is something, is a deviation that we need to find also why this happens. This retrospective statistical analysis helps a lot, especially in the case when we are not able to find a suitable benchmark norm for our process. And then once we located an area of opportunity or priority area, we start asking questions. What is the reason for this deviation? Why do we have generation of waste at this particular point? Why do we lose our milk, for example? Why do you lose, for example, already dry fruits at our company? And we are asking questions. And there is some methodology that we have discussed last time, that some standard approaches how to delineate problem through the standard categories. Like, is it that raw materials are wrong or something happens with handling of raw materials? Is it that people are making mistakes? Is it that we cannot control the production process properly? Is it that our technology, our process line is obsolete, shabby, and outdated, and then simply we cannot avoid losses, things like this? But we have some standard categories that could provide us answers to what the problem is. Important in our cleaner production methodology is that we are not just simply accept that, okay, this is waste, and it should be like it is because it has been generated for ages before. No, we try to ask questions. Why do we experience waste? Is it really that we need to lose some product or some raw materials, or we could do something with it? And then I would like to point out once again your attention, especially for less experienced persons, for the novice. It's not so easy, and you don't have yet broad vision and broad experience. Use the standardized materials that have been prepared by others, because somebody somewhere has already approached similar problems, similar issues, and have reported on potential answer or solution. Try to collect best practice examples, best practice references, case studies. And we, from our side, we try to ease your task, and then we have introduced to you standard checklist prepared by UNIDO and UNEP, United Nations programs, that have been working with resource efficiency and with cleaner production for many, many years. They have prepared already some standardized approaches how to handle standard problems, because most likely issues that our companies are experiencing are quite standard. They are more or less typical, and we might be able to find references to potential answers. So we have introduced to you the checklist for generation of measures, and we would encourage you to use it. And if, for example, an issue is a water consumption, that we have a feeling that our company uses a lot of water, we have a feeling that it's not just water that costs them, but it's also energy. We want to do something with this. Then this checklist would suggest you a range, a list of standard techniques or approaches, what could be done with the redundant water consumption. And they, for example, say that install water meters, not just have 1 meter, but also have meters in your departments, introduce sub-metering of water consumption, so to be able to follow, to trace water use at the main process. Maybe you should establish water monitoring program. Maybe you should go through the production process to see leakages of water, and maybe you could substitute water-based cleaning with dry cleaning, things like this. There are lots of standard approaches, and you might be able to find something that gives a clue to the problem at your company. So please don't hesitate, and I would encourage you to use this checklists. Today, we would focus more on standard opportunities, on standard approaches with regards to water, with regards to energy, with regards to material use. We will go a little bit deeper on standard approaches, standard techniques that are applied by different companies, that are replicable on many instances. And we would also speak about nuances and specific features of energy efficiency for compressor stations, energy efficiency for boilers, material use, raw materials, control of final product quality. What are potential here and there, what is experience from other programs. This is our main tasks. And if you also please also note that you will also have the possibility to train yourself or exercise yourself. You will get a possibility to watch a very interesting video, and then based on this video is try to show your creativity and generate potential measures, generate ideas that could save a lot of money for a specific food company. Look forward, and very interesting how it will go. We would together with you as trainers and try to help you in this process. Tomorrow we would focus more on feasibility assessment. Once we have developed our measures, once we have prepared the list of what could be called as a measure, we need to look if they are feasible, because at the very initial point it's still an idea and we don't know how realizable this idea is. Is it technically applicable? Is it economically feasible? Does it provide environmental benefits? And we would have to analyze to finally select those measures that could be considered most feasible and have largest chances for implementation. This important process, assessment of the measures, technical, environmental, and economic, we will touch upon tomorrow. And then we would more or less ready with theoretical content of our training. But we will continue our practical work, and we, as trainers, will continue rendering our support throughout the whole summer period. But we also expect from your side that you would also proceed and with your reports, and you will try, make efforts, put your time, do something, and then if problems arises, if gaps in information arise, we will be available for guidance. We would be available for very informal and very friendly advices. This is about what we are going to do today and tomorrow, and what we have done last time. Thank you. Do you have any questions? Are there any questions? Could you hear me?
Yes.
Okay. You could hear me. Then I assume we could go to the main content of our session.
Mm-hmm.
And I will stop sharing this screen, and I will put another presentation on. Is it okay? Can you follow myself? Or should I speak a bit slower, at slower pace, or stop a little bit?
Everything was
okay.
Everything was fine. Yeah, everything was fine.
Okay, thank you. So then we proceed to another presentation. Let me see. How could I do this? Just a moment. Now we are going to touch upon um, touch upon new subject. We're going deeper into details. We have so far been making analysis of our production process. We have prepared mass and energy balances. We have highlighted most acute problems or priority areas where we could expect the maximum gains in terms of savings, in terms of reduction of losses. And some of these priority areas might have to do with the use of materials, with the waste, solid waste generation. And this is what I want to focus in my presentation. So you could see my screen, right?
Yeah.
Yeah?
Yes.
So we go. So the main subject now is the solid waste generation and the use of raw materials and the production of final product. Why are we concerned about this? Because we know that for maybe for 10, 15, 20 years, raw materials were relatively cheap. And the cost of losing these raw materials was not so expensive. But now the situation is very, very different. The prices on raw materials are growing all the time, from year to year, and we cannot afford any longer losing a lot of raw materials. We cannot afford losing our final product or semi-products. We should keep control and reduce the generation of waste. And as we discussed last time, that the true cost of waste sometimes is, or very often, is different from what we expect. Because whenever we process our raw materials, we invest some time, we invest energy costs, we invest water costs, etc. We invest labor costs in our product or semi-product, and that is why it is so much pity and it's so much sorrow to lose it. This is important to hold good control over the wastage in our company. And let's see how we are doing this. We have discussed the overall methodology. You already are introduced to this. We prepare process flow sheet or process flow chart. We locate the main processes. We locate main flows that come in and come out at each main step of the production process. And we try to see where we lose. What flows could be attributed to waste flows. And once we identified where we experience where we are suffering from losing our raw materials or semi-products or final product, we try to make a structural analysis of this situation. And we ask ourselves, why do we use materials here or there where we experience losses? And what is the reason the waste is generated at this particular process, at this particular step of the process? Is this loss stable, or are there any factors that would influence the quantity of waste generation? Probably at this point we would retrieve some statistical data, trying to understand whether the waste generation is constant. And once we understand the reason, we try to address something that will cut this deviation, that will reduce or minimize or avoid the wastage. This is the cleaner production and resource efficiency in core. We locate the problem and we understand how much do we generate in terms of waste of byproducts, and we try to analyze why do we do this, and we never accept ourselves that this is like it should be. We always try to think, could we do something with it? And I'll give you an example. A factory that produces ceramic pots. The way they have analyzed their problems and try to identify possibilities for improvements through the standardized approaches. They were thinking, they try to split the problem into major categories like impact of raw materials or inputs, impact of human factor, impact of process control, and etc., etc. And then they have been thinking: is it that the quality of clay they use for ceramics is not good enough? Is it that the way we are molding this clay, is not good? Maybe people are not very competent in doing this. Maybe we did not stick to the initial recipes as appropriate, and maybe the kiln that we are using to anneal the semi-finished product pots, maybe it doesn't work well. We could not maybe control its temperature, or maybe different zones in this kiln, they have different temperature, so that the surface is annealed unevenly. Or maybe the design of our pot assumes that there are some handles that are very weak, and that's why if someone touch them, they will be easily broken. And finally, if there is a waste, if there is some clay which is rejected, could we reuse it? So they try to split this problem of generation of broken pots, ceramic pots, into various categories that we have actually discussed last time. Remember, we have had the presentation which is called cause and root analysis. This is where we have discussed the standard categories. They have done this, and they try to find what is the cause for our problem. And then when they have done this, when they have separated, split the problem into small segments, smaller bits, they came up with, through the brainstorm, they generated lots of ideas. They told that, okay, if the quality of our clay is not good enough, so maybe we should buy more expensive clay with less impurities. Maybe then we would suffer less losses. Of course, our sales department, our procurement department will tell, why should we buy expensive clay if we could find a cheap one? But maybe by doing calculations, we would arrive at that our losses are much more expensive, that we suffer much more expensive than the difference in the price between the clay. Then maybe people need better training or more strict control to make sure that the original recipe is really followed. Maybe our kiln is not good enough. Maybe we should buy a new one, or should buy a new burner to have a better possibility to control the temperature in the kiln, because it's a gradual process of rising the temperature and cooling down the kiln. And if we are not able to follow it, then the strength of ceramics will suffer. And etc., etc., etc. So they split main problem into categories, and they try to find answer. Of course, not all of these ideas would be suitable, but this is a brainstorm. We will never say it's wrong or correct. We will first generate an idea, and after that we will proceed to its description and assessment for feasibility. So once again, this is an example of how we could assess a problem, how this problem could be split in much smaller and much more narrow categories, and how could we generate possible answers to these subcategories of problems, of causes. This is what I would hope that you would do with your companies. And in these and further presentations, I try to collect examples that would resemble your companies, that might be applicable at your companies, that you would see how people at another companies, in other countries have been thinking, how could they arrive at solution? That because the same method is, I'm sure, is 100% applicable with your companies. Now I will give you some example of standard approaches with regards to our struggle with wastage. For example, if we are looking at raw materials, and if we see that the quality of raw materials, something happens with the raw materials that we lose them, or the quality of our final product suffers from raw materials, what we do is a standard approach would be to apply more strict inspection of the quality of raw materials. And it's very common that we have laboratories, we have special personnel, we have a special checkpoints that will make a harsh control over what we are putting into the process. We would probably think that it's difficult to maintain good quality if we use too many varieties of our raw materials. So maybe we want to unify by less different varieties of your milk, for example, of your sand, for example, etc., in order to be able to keep better control over raw materials. And then, of course, once we purchase some raw materials, we purchase them in batches, but the production process do not follow exactly the procurement plan for us. So we need some space to store them for some while. And it is often that the companies have poor or insufficient storage conditions for sensitive raw materials like milk. And then we would observe if this is a problem, or we could do to make sure that adequate storage conditions are applied, and we do not lose useful raw materials. And then also we could ask ourselves, okay, now it is already February. We do not expect to receive a wave of mandarins. We would probably get much less mandarins to our factory than a month ago. So do we need to buy so much mandarins? Do we need to keep them for a long time at our production site? maybe we could optimize the quantity of mandarins that we are purchasing somehow through the special contracts, in order not to keep too much raw materials at our site. And the same, there are some also standard approaches to final product, because when we lose final product, it's a tragedy, because it's expensive. We want to sell it. We don't want to lose it. And we need to apply special precautions for in order to try not to lose final product, of course. And this is it's important that we analyze, maybe in our final product our storage conditions for final product are not good enough, or maybe other way around, we have too over specified final product. That we spend too much money on and too much resources on its production. Maybe we could follow the traces of our Chinese friends, and we could use cheaper materials, or use less materials for producing our final product, and then we could save on costs. I think what I would further go into very interesting subject is materials efficiency and what we are doing during the production process with handling operations, with semi products, with controlling our production units, of their controlling operation efficiency of their operation. We would probably typically we have lots of food companies where we have batch process, and we probably would not want to start up and turn down our production line too often, because we will need to clean it, and then we will lose some product and generate wastewater. So we probably, our planning department should try to plan our production so that avoiding too much changeover of products, or too much, and to avoiding that we are stopping and starting up our production process too often. And then we should probably also look at our belts, at our machineries, the way they're set up, so that they do not expose any damage to our products or semi-products. And if, for example, we see that waste is generated here and there, we don't want to put waste together. We separate it, because some parts of the waste maybe we could put back into the beginning of production process and recycle it. This is also a very typical approach for struggling with waste. And experience shows that in human factor is also very important source of such losses. By better training of operators, so that they mind generation of waste, by better operation and maintenance of equipment, we could achieve significant reduction in waste generation. Sometimes we are very focused on plant utilities, on support systems, and because they're visible, if there is a leakage, we could see this. But I think it's for us much more important to analyze production process and to see where we generate waste, because the cost of waste also includes the cost of energy, includes the cost of water that we are using, includes the cost of labor, includes the cost of raw materials. It's very expensive. That is why it is very important not to simply believe that we are a waste-free company. Go and see what happens. Maybe it doesn't happen today, but maybe it happens if something occurs. We should find out, and then we should try to minimize or prevent generation of waste. Waste is very expensive. Here at the next slide, I try to give you some examples from real companies where I've been working, which I feel like that these examples are could be relevant for the companies you are working with. Examples of process control. We sometimes underestimate the importance of this technique, of this task, but very often low-cost measures align within the better control of production process, with small measurement units, with introducing new routines for calibration of equipment or for maintenance of equipment. We could often achieve very, very serious savings. There was one company, dairy company, and they have experienced problems with the quality of their milk, and that is why a significant part, up to 10% of the milk, was not taken by the retail outlets. And then they found out that the process of pasteurization is working not well. They don't know exactly the temperature, if they achieve the required temperature at the pasteurizer. So they have decided to make a small improvement in their process, in their production process, by measuring small device that measures flow of steam that goes into the pasteurizer. They've been able to much better control and regulate deliveries of hot steam and its properties at the pasteurizer, and they saved a lot of money on this, reduced the loss of final milk by 50%. Another company, juice maker and winery, they use back filters, but they have not been measuring the pressure loss in this back filter, and sometimes they use a lot of energy for this back pressure process. And then they started measuring the back pressure, and this had significant effect at the cleaning process, at the cost of their cleaning and the use of water. Also, things like in food industry, things like conductivity meters, pH meters, have a lot to say in this branch. So several companies have decided to introduce such measuring points, and which do not cost much, but provide better control over the quality of the production process. So these small devices, small controls often have significant meaning in terms of savings. We also have office costs, and they sometimes are not attributed to production process, but offices often produce paper. They offices we also do some manual operations, things like this. So it's important that we also keep control about the household waste that generates in our offices. And standard approach is separate paper from bio-waste, for example. A standard approach that could be relevant in our case is that we especially has to do with the companies that have been growing gradually. Sometimes production lines, they comprise of old and new equipment units, because the company doesn't have financial means to buy a production line as a whole. So they buy step by step new equipment. And sometimes we suffer some significant problems that we would have a shabby unit, an old packaging, for example, machine in a relatively new production line that has another capacity, for example, of production. And that's why we have to wait a lot until this critical piece of unit will be able to manage to handle with its batch. There is one methodological trick where we make a graph and write down capacities of all main units of our equipment units of our process line, and write down capacity. And if sometimes we will find a bottleneck, for example, and we would understand that here we lose a lot of money, because this bottleneck doesn't allow us to produce more. And this bottleneck is probably is where we lose the quality of our product, or where the waste is generated. At larger companies, but also very much has to do with food and beverage companies, production planning is very important. Imagine if we have, for example, a company that produces various types of jams. If we don't have proper production planning, we will change over the product quite frequently. And to change it over and to start producing new type of jam, we'll have to clean the old one, clean the reservoirs, vessels, pipes, etc. And with that, we will lose some of the useful material that remains in the pipes, remains in the production line, and we will generate lots of wastewater. What we could do about this? By trying to predict, maybe by extending our storage space, we could reduce number of the changeovers. And changeover is always about extra costs, cost of energy, loss of product, use of extra water. We do proper production planning, maybe based on the software, and then we will normally save a lot of money on our losses. Also important that the management of the companies, they are aware of importance of maintenance, regular preventative maintenance that would prevent, for example, accidents with the stoppage of equipment or sudden repairs. This is up to the management to plan it. So it's an important part of our overall strategy of managerial strategy is to make sure that the operation and maintenance is very well scheduled, is documented, and is properly done. Just give you one more example from a company that has similar production profile as Tileti poultry factory. This company has experienced problems with generation of manure. It was a huge quantity, and they didn't have a site where they could dispose this manure. So they have been doing well. And then initial answer was what we could do with this manure. Nothing. It will be generated anyway. But then through the assessment, a bit more diligent assessment of their production practices, we found out that the manure builds up excessively. It's mixed up with urine, with water, and then its quantities are much larger than it should be, and its humidity is almost like a water. It's a very liquid manure, which should not be. And then of course we need to use much more space for the disposal, but we also need to use much more transport to evacuate it from the factory. So we have discussed why do we mix. There is a infiltration of water into manures. Okay, we found out that the pens which feed the chicks with water, they are not very well designed, and then it's very difficult for chicks to drink water from it if they are very tall, and a lot of water is just running down. So we have suggested to change this the design and calculated the costs, but turned out that the benefits are at the same level as costs, and we would get our investment back in 2 years, which was very sufficient for this company. We also were thinking that maybe we need to develop a much better strategy for the waste management, manure management, and maybe we should think about biogas reactor that would produce energy for our company. So this is a standard problem, and you could see that some standard ways of thinking how to solve this problem. I don't want to spend much more of your time on this subject, but please remember, the cheapest ways and the best is to avoid waste, minimize waste. Otherwise, reuse it or recycle it. And just at the very end of this ladder is the disposal, the most expensive way of handling waste. The cheapest is avoidance or minimization, and the most expensive is disposal. And 1 more or 2 more minutes of your time, I want to give you a comment. At several of the companies we are currently working, we see that they recycle their waste. They lose some product, but then they put it back into the beginning of the production process, and they feel like that they do not have any wastage. This is not true, because recycled product is already much more expensive than your raw materials. And when we put it back into the production process, then our raw materials in turn they would cost much more expensive. So your companies should be aware that recycling is expensive, and it's of course better than simply disposing your waste, but it's much worse than avoiding this loss of material. Please do everything what you could do before you recycle your raw materials in the production process. Thank you very much. Once again, please use the checklists that you've been given. Use best practice information, collect information on internet. The type of companies you are working with could not be called as unique companies, high-tech companies. There are lots of similar companies and lots of experience already accrued. So look forward to see next time we meet more measures related to prevention and reduction of waste. By reducing the waste, we reduce lots of costs for the companies, including the energy and water. Thank you very much. I just think that we need to take a fresh breath, maybe, and because the subject is a little bit tough. So I will give the floor to my colleague Dmitry Laznenko, who will comment now on our very nice encounters and meetings last week, where we have discussed the progress of our reports. And then after that, Dmitry will give the floor to myself. Again, we will speak about energy efficiency. Dmitry, here you are.
Добрый день, уважаемые коллеги. Сейчас я попробую прокомментировать некоторые вопросы, связанные с нашей с вами работой, с работой над конкретными вашими задачами, предприятиями. После нашего общения в режиме индивидуальных консультаций я хотел бы сделать несколько общих таких аспектов, да, отметить, а дальше пройтись по конкретной работе в качестве примера. Ну, из общего, конечно же, каждая практически группа столкнулась с определенными сложностями внешними, которые связаны с нестабильностью работы определенных компаний, с какими-то сложностями в получении той или иной информации, наличие определенных пробелов. И здесь, конечно же, в разных группах это проявлялось в разной степени, но однозначно очень сильно было заметно, что даже в таких условиях каждая из групп намного больше погрузилась в свою работу, намного выше демонстрировала понимание процессов, с которыми вы работаете, даже в таких сложных ситуациях. Вот. И прогресс просто был, как, по моему мнению, очень значительный. Второй момент, который я бы отметил, что от, ну, наверное, каждой группы я уже слышал так или иначе фразы, что вот если мы еще раз или когда мы еще раз попадем на предприятие, то мы уже совершенно по-другому будем задавать вопросы. Мы совершенно по-другому посмотрим на те или иные производственные и организационные вопросы. И также в некоторых случаях вот кто-то из вас говорил: покажи, можно ли посмотреть чужой отчет, как это делают. Сейчас мы попробуем пройтись вместе с вами, посмотреть не чужой отчет, а один из ваших, и посмотреть вот вместе с вами, как одна из ваших групп подходит к обработке материала, к его представлению. Это действительно хороший уже продукт, который можно смотреть, можно комментировать. При этом он не является окончательным. И сейчас я открою вам экран. Буквально одну секундочку. Вот, мы с вами видим отчет по группе номер 1. Это компания, которая занимается производством яиц, выращиванием курей. И вот вместе сейчас будем идти с комментариями и просто посмотрим, как это вот выглядит и на что мы обращаем внимание. Ну, смотрите, отчет, да, 1-6 глава, по факту мы имеем на данном этапе еще только 1-4. Остальные еще в процессе подготовки. Значит, раздел номер 1. Все, тут даже, видите, примечания есть, которые я писал, когда просматривал. Вот, все достаточно лаконично, четко, понятно. Я хотел бы, чтобы в целом еще подчеркнуть вот такую как бы идеологию всей этой работы. Все, что мы в отчет вставляем, эта информация, мы должны понимать, что она достаточно практичный, имеет характер. Нет задачи сюда написать много информации, а задача в том, чтобы именно вкладывать в отчет информацию, которая представляет ценность для понимания общей картины, для ее представления тому, кто будет читать. И в процессе работы бывает очень часто, что какая-то еще информация все равно может редактироваться по мере ее уточнения. И к этому также я бы относился достаточно гибко. 1.2 тоже, вот хороший пример, все четко представлено, ничего лишнего. В 1.3 могут у кого-то из вас быть немножко по-другому подходы. Здесь, опять же, достаточно для понимания информации описание, достаточно через визуализацию понятна структура, она достаточно простая. В других отчетах есть более детальное описание, и это тоже хорошо. То есть вы каждый должны для себя делать так, как для вас удобно, как для вас понятно. Вот. Ну и понимать, что кроме вас может кто-то смотреть другой человек, и, соответственно, легко должен это все воспринимать и понимать. Вот вопрос отображения экологической политики. Мы говорили о том, что классически экологическая политика – это документ, который содержит в себе определенные экологические приоритеты, определенные экологические обязательства компании. И у многих компаний именно в формализованном виде такой документ он может отсутствовать. Об этом наши участники показывают в отчете, что да, документ такой отсутствует, нет в этом ничего такого особенного. Но при этом компания имеет определенные экологические приоритеты, которые не зафиксированы прямо так строго там, документом, да? Но в результате посещения, в результате общения этот факт был отмечен и показан в отчете. Все отлично. Ну, просто молодцы, можно сказать. Дальше следующий, да, вот раздел, там 3 уже пошел. Тоже достаточно хорошо, информативно вот, показана вся ключевая информация о производственных мощностях, о площади, о конструктивных особенностях зданий. Это не говорит о том, что у каждого должно это быть. Просто для данной конкретной работы, вот для них это важно. Для кого-то, возможно, важность меньше. Вот. Особенности энергообеспечения, режимы работы. Даже вот просматривая этот отчет, я попросил буквально в пятницу его обновленную версию и уже заметил, что некоторые вопросы учтены, которые мы обсуждали в режиме индивидуальных консультаций. То есть достаточно оперативная реакция и, ну, честно говоря, вот приятно смотреть и смотришь, вот все понятно, все хорошо визуализировано фотографиями, теми, которые вот имеют значение для данной конкретной работы. 3.2, да, раздел. Тоже вот описание технологического процесса. Опять же, вот сравнивая даже 2 отчета, которые нам был предоставлен до консультации, и вот этот более свежий, уже в нем информация уже дополнительно еще немного систематизировано, более понятно некоторые вещи. Вот, немножко есть редакционные такие, также корректировки, которые еще как бы улучшили восприятие этого материала. При этом, опять же, вот по нашему мнению, некоторые вещи можно было бы еще и уточнить. Ну, например, на данном предприятии есть несколько видов энергоисточников, которые используются, и эту информацию можно было бы немножко детальнее отобразить на блок-схеме и в описании. По нашему мнению, это бы добавило несколько информативности. Мы этот вопрос проговаривали, и думаю, что просто еще не успели быстро отреагировать на данный момент, на данный аспект. Тоже вот таблица 4.1, да, всем вам знакомая, она вызывает у многих из вас сложности. И также уже вот эта таблица, она уже вот доработана после нашей консультации индивидуальной. При этом я бы хотел обратить внимание, что все равно вот намного больше уже информации, но необходимо еще внимательно отнестись к тому, что некоторые вот отходы, например, здесь не представлены, а дальше в описании они присутствуют, такие как падеж цыплят, курей, возможно, еще какие-то данные есть смысл верифицировать. У меня не было возможности, просто один день я его смотрел, обновленную версию, не было возможности детально все проанализировать цифры, вот, к тому же, что их стало больше. И как результат систематизации этих данных уже в таблице 4.2, вот уже эта информация уже позволяет выполнять определенный анализ. Хотя я так думаю, что она будет также несколько уточнена, исходя вот из сказанного выше. Здесь вот мы видим, да, первая группа, среагировав на наше общение в таблице 4.3, это я желтым выделил, дополнительная детализация энергопотребления, которую мы обсудили, и наши участники их постараются добавить, и, соответственно, немножко здесь тоже цифры будут уточнены. Вот, и вот представление графической этой информации, скорее всего, также будет немножко подкорректировано. И по результату будет более четко уже либо подкреплены предположения данной команды о актуальности тех или иных мероприятий, либо наоборот они поймут, что актуальность ниже. То есть мы еще не знаем, мы увидим цифры, и тогда более четко будет понятно. Экологические воздействия. Экологические воздействия, конечно же, вот я еще один момент здесь обнаружил. Из обновленного отчета здесь выпала, видать, чисто технически информация про ключевые показатели эффективности. Этот вопрос мы обсуждали. В предыдущей версии здесь таблица была, но я подозреваю, что это чисто технический аспект, и мы ее увидим в следующей версии, и, скорее всего, уже, может быть, с какими-то данными. Вот. Относительно экологических воздействий. Конечно же, полный набор экологических воздействий, он больше, чем указан в таблице на предприятии. Однако наши вот, участники группы номер 1, они представили имеющуюся информацию, это хорошо. Если другая информация на предприятии отсутствует или недоступна, то мы анализируем то, что мы можем анализировать. И я хотел бы еще раз обратить внимание на то, что для вас не должна ставить в тупик ситуация, когда отсутствуют какие-то данные. Такое может быть часто. И нам нужно работать опираясь на те данные, которые имеются. Один из основных принципов экологического менеджмента – это метод последовательных улучшений, последовательных уточнений каких-то данных. Поэтому это абсолютно нормальная ситуация, и ее нужно нормально, как бы спокойно к ней относиться, и она не должна останавливать нашу работу. Просто мы понимаем, что, возможно, мы ее уточним или уточнят без нас на следующем этапе развития системы. Относительно перечня приоритетов, я сейчас не стал бы их комментировать. Они здесь указаны в таком виде, в котором команда их видит для себя. Дать свою оценку этим пока приоритетам мне сложно, потому что нужно опереться на более полную, более точную информацию, которая уже у команды присутствует, но просто мы ее еще не всю видим. По форме представления все хорошо. По сути, я думаю, что вполне может здесь что-то еще быть добавлено или подкорректировано в процессе работы. И в конце мы даем некоторые, это уже дополнительно комментарии к продолжению работы. Сейчас их нет смысла широко комментировать. Это уже группа номер 1 их проанализирует для себя. К тому же некоторые из них вот уже виден прямо прогресс за несколько буквально дней работы. Очень приятно работать с таким документом. И есть вся надежда на то, что мы будем иметь хороший какой-то результат, и у наших участников есть еще дополнительные интересные идеи, которые уже были рождены буквально вот-вот. Спасибо за внимание, я надеюсь, что это было для вас полезно. Я передам сейчас дальше Сергею экран для продолжения нашей работы. Так,
Спасибо,
Сергей.
Дмитрий. Очень интересно. И благодарю группу за то, что прислала нам оперативно этот отчет. Let's do it in English now. I will now proceed through our program and will focus our attention at something that most of us are very concerned with, at energy efficiency. This is the subject which is, I think, very close to minds of most of us. Could you see my presentation?
Yeah.
Yeah, Elena, thank you. So I will go through the analogy, more detailed analysis of energy flows. And we, of course, are all aware that energy is now very expensive. And this is where our companies are seeking support at first hand. That is why a significant part of our work is analysis of energy efficiency, but it's important to make it quite systematically and to focus our attention at those points where we could expect the largest savings. So let me go. Well, the overall strategy, the overall methodology for analyzing efficiency of energy use is quite generic. We first locate the main users of energy, and this is actually, you probably have seen in the template section, I think 5 of our report. We locate all the main energy users. We try to attribute to these energy users the energy consumption. If it's difficult to collect the actual data, we assume their energy consumption. If not possible to assume energy consumption, we would probably know capacity, energy capacity for the main users. And this is how we could also make ranking. And then in best case, we find those who consume most of energy, those users that consume most of energy, and we try to collect data related to these energy users. And when I say energy users, I mean pieces of equipment, departments, special processes. And then we try to see what are the main factors that influence the energy consumption for these selected most important energy users. Is it that the weather controlling energy use in the department for chicks growing at our poultry factory, or is it the energy is controlled by number of quantity of eggs which are produced, or number of chicks which are residing in cages of our chicks department. So we try to identify which factors control the energy use. How this is done, you could revert to the first session, the presentation, which is called Energy Monitoring and Targeting. This is, we have discussed there how to monitor and how to establish targets for energy consumption. But let's say we have collected data, we have prepared some developed graphs, and we would understand then how the energy performance varies over the time, or varies depending on the rates of production or ambient temperature. And then we would try to establish some norms, or to establish some sort of benchmarks to see whether we are on the right track or not with regards to energy consumption. And as I got impression, for example, from our companies through the individual consultations last week, most of companies believe that they are efficient, and we should be critical about this belief. We should verify, and the only way to verify if they're efficient or not is to see how their consumption compares to certain norms or certain benchmarks. And also, when we are looking into the energy consumption patterns, we try to see whether equipment is loaded as properly loaded as appropriate, or it's underloaded or overloaded. This is also important. So we not only, especially when it comes to power, we are not only tracing the actual energy consumption, but we also try to trace the rate of capacity utilization. So if we, for example, have a pump with the capacity of, for example, 10 kilowatts, then we come and measure whether this pump is running full speed or not. Maybe it's running half speed, and then we make conclusion that it's only half of the capacity of this pump is actually utilized. So this step-by-step process leads us to certain conclusions with regards whether this process is efficient in terms of energy consumption or not. And once we have seen that here we could gain some savings, here we could reduce the energy use, we try to spot what are the reasons for overuse of energy or for energy losses. And then we think how to reduce these reasons, how to prevent inefficient energy consumption, how to be more effective. So this is actually the same methodology as applied for the assessment of waste generation, but only we look into energy. And quite likely, since energy is energy, we don't see it. It's quite likely we would need a person which has technical background, hopefully energy background, that knows how to calculate energy use, how motors are working, how air compressors, what is the difference between screw and piston compressor, things like this. So energy requires some technical knowledge, but hopefully and luckily, you at this particular program, you are working with Energy Efficiency Center that has a exhaustive and comprehensive overview over energy efficiency approaches and strategies. So at this particular time, you are very well back up and supplemented with up-to-date knowledge on modern and energy efficient applications. Let me give a very quick overview of standard approaches with regards to energy efficiency. I know that there is lots of information I could provide, but I need just to pinpoint most essential parts. For the rest, I would advise you to read through the presentation, and you as experienced and competent specialists, you would probably understand my notions and statements. But of course, the frames of this presentation are not as wide, so I would not be able to focus on each slide with the same level of details. So please allow me to jump sometimes. But tell me if something is unclear, I will try to repeat. The subject is very broad and very interesting. So what are the main opportunities or main strategies, techniques for saving energy? Well, first of all, when we come over and visit our company, go through the production process, perform some kind of energy audit, we would probably find certain places with direct leakages, where we would see that the steam is flowing out of the pipe or flashing out of the pipe. We see that for example, some machines are running in the idling, although they should be idle during the downtime. We would see some ice built up on your in the cooling storage on the fins. These are all obvious signs of energy leakages, which could be prevented by better insulation, by repair, by preventing drops, dripping, flashing, and things like this. This is quite obvious, avoiding direct losses. But sometimes, but even more ample benefits could be gained from avoiding misuse of energy or inappropriate use of energy, using energy where we don't need energy to be used. For example, I've been once at a company. It was a very local branch of an international beverage company, and they have been blowing plastic bottles. It's a very hot process, and operator was sweating all the time. So they put air conditioner at a small post where operator was sitting. But here, 1 meter away, they were blowing, they were putting, they were having mixers for smelting PVC granules. So the capacity of air conditioner was not enough. So they put one more and very heavy air conditioner. And then they started experiencing problems with the smelter process, melting of plastic. So they added some smelting capacity to the smelter machine. So that will be to be able to maintain right temperature. But then operators started to smell to sweat again, and they decided to put one more air conditioner. So it was a typical example of inappropriate use of cold energy at the point where it should be very hot. So by simple insulation or putting a video control and by letting operator to see it more distantly, they could have been avoided large investments into new air conditioners and new mixing machines. So this is a typical example of inappropriate energy use. So avoid the areas where we don't use energy, where we don't need energy. Then the third direction, and the second direction is usually often low cost and very, very profitable, very profitable. So be please always critical. Why do we use energy? Maybe we don't need energy, or maybe we don't need so much energy to be used. For example, we don't need to produce steam if we have a pasteurization, if we need to pasteurize our milk up to the temperature of 80 centigrades. Maybe hot water will be enough, will be sufficient. Or maybe we need a steam, but the pressure of the steam is redundant. Maybe we can stop our conveyor belt where it is not needed, or for example, we could put our product, for example, chocolate plates, more evenly on a conveyor belt, so that it will occupy much higher area at the conveyor belt, so that the working time for conveyor belt could be reduced. So we could we probably sometimes will find that we use excessive energy and we could reduce its use without negative consequences at production process. And then we probably also could find out that our motors are low efficient, are old, or maybe our boiler is also quite old. We could put new machineries with higher efficiency factor, so that we could maximize so-called conversion efficiency for our units. And if the previous strategy are not possible, maybe, and we still are using a lot of energy, and a lot of energy is wasted. For example, we have compressor station, compressor plant, and there is a lot of heating energy, thermal energy as a byproduct, from the compressor. Maybe we could do something to recover process heat at our dairy or cheese maker, and to use it, for example, for showers at our office, at the office of this dairy company. Or there is another company that we are working with, which has a steam boiler, maybe some condensate, the condensate which is currently put down the drain, could be recycled. And this is a typical measure for the waste heat recovery. And then another opportunity which we have discussed already, if, for example, we're using our boiler is run on a very expensive natural gas, maybe what we could do to put solar heaters and to use solar energy, or use another fuel, for example, biomass, which we might have for free, for example, for our company that produces dry fruits, maybe we could do something to avoid redundant use of natural gas for the dry process. So this slide shows you standard directions of how we could save on energy use. The energy use is unstable at most of the companies. And there are various factors that influence the energy use. We probably should find out which factors control the energy use. And if we find these factors, then the chances are pretty high that we would be able to suggest any improvement that would reduce the redundancy in the energy consumption. So we use the energy, and we should understand which factors control this energy use. Why do we use so much energy or so little? Why do we use twice as much energy during the winter time compared to the summertime? Why during the night time or public holidays, when the company is not operating, we still experience significant energy use? Why? And if we find an answer, for example, to this question, we would be able to develop preventative strategies to avoid that we use energy during the downtime periods. But energy is invincible. So you need, once again, certain professionalism, certain competence to be able to measure energy, to quantify the energy flows. But it is not always that you need very advanced and sophisticated equipment to do this. You could assume the energy use, you could do the temporary measurements, you could make trials, etc. For example, we have a poultry company in our program which comprises of 2 production departments. One production department is a department for chicks, for growing of chicks. And another is for eggs production, where the grown chickens are. And chicks, they have very different energy demand or temperature demand at different age, at different weeks. But the grown chicken, they just sit and produce eggs, and they don't have very different and variable demand in energy. So we know, for example, that now in April or now in May, Department of Chicks is closed down for some while, for example, for 1 or 2 months. Then we have a very unique situation when we could measure efficiency of energy consumption by the second department of grown chicken, and to see how effective we are in using energy in this department. This is just an example of how to solve a problem when we don't have lots of meters. I would like to also point out your attention at very important for us energy auditors subject. If we look at the energy systems could be energy system of Tbilisi, it could be energy system of a small village, but there is this energy system of a production company. Then it could be split into energy consumption processes, for example, process equipment that needs power. We also could split into energy utilities. This is, for example, the power lines in our company, or steam lines, or compressed air lines in our company. It means distribution systems. And energy generation or conversion systems. For example, it's a power transformer station at the inlet to our company. It's boiler system, for example. It's compressors. It's all the equipment that generate some form of energy or convert from electricity to, for example, cooling energy or thermal energy, etc. There are three elements of this system at each company, and then they make a loop. There are three loops, or typical, as we call it, a process onion. The end use is in the middle. Then, for example, we have a boiler system, boiler house, that generates energy at certain efficiency, for example, 90%. They produce hot water at 90% efficiency. Then we have pipelines that bring this hot water to a process department, and there are some losses. The pipelines, the distribution system for hot water also has certain efficiency, let's say 95%. And then this hot water arrives at our, for example, asphalt making process, or for example, pasteurizer process, which also has certain efficiency. So in fact, we have three processes, each has its own efficiency, and the final process has efficiency, which is a factor of its own efficiency of own process and using equipment, of efficiency of distribution systems or plant utilities, or efficiency of energy generation or conversion equipment. If we reduce the end user demand of energy, then we reduce losses in distribution system, and we reduce also losses in energy generation or conversion equipment. Whereas if we target our energy efficiency measures at a boiler, at a compressor station, at a power transformer station, then we only reduce losses here, only at one element of the system, but we do not influence or induce anything, energy performance patterns here at energy consumption or energy distribution. What could be the conclusion from this? The conclusion is that experienced energy efficiency experts would always understand that reducing end user demand is probably the most profitable activity to save on energy. And then he will always start from understanding why we need so much energy for our end user at end user side, for our process equipment. Then he or she will go to distribution systems, and then at last hand at boilers, at, for example, compressor stations, etc. Because when we address savings or improvements at process equipment, then we at the same time reduce losses in distribution system and in energy generation capacities. And this is what I would do. I would always start thinking why do we use energy? Why do we use so much energy at production process, at technological line, and only then we'll go probably to analyze compressor stations or cooling chambers or ventilation systems, or for example boiler houses. If I remember, many of you, when went for the first time for the companies, you have started your work, your assessment from the very bottom of this energy ladder, at analyzing efficiency of energy generation conversion equipment, boiler houses, compressors, etc. And I think when you would go next time to your companies, I would strongly advise you to assess efficiency of energy consumption at the process, at the heart of the process, because normally it will bring you the largest savings. And I'll give you some, for example, an example. There is an end user process. There's a process line, and we have a unit of equipment that needs energy. And then we start analyzing why energy is used here, why as much as currently used energy is consumed at this equipment unit. Is there anything we could do to reduce load on this equipment piece by regulating quantity of product that is that arrives at this machinery, or something else? Are there any parameters that could be better controlled or regulated, set up, that could reduce demand in energy? Things like this. We would ask, and if we find possibility to reduce the energy consumption of this unit, then we will also reduce the demand in the energy supply, in energy distribution, etc., etc. One more example. For example, we have a pump station. This is a pump. It receives electricity, and then we want to understand what we could do to make this reduce our costs, energy cost on pump. And then, first of all, we ask ourselves: is this pump doing useful work? Firsthand, we ask: is it possible to somehow to make to lock the pump when it's not needed? Do we have any routines for that? Maybe we could schedule operation of the pump. Maybe we should, instead of having one large pump, we could make two smaller pumps working in parallel, and then if we experiencing, for example, variable flow to go through this pump, then at low flow only one pump could be working. But then the next question, which is closely related to this, to this energy ladder, we ask: is this pump doing right work? Do we really need to pump water so high? Maybe we could reduce, maybe our equipment could be positioned much lower, so that we don't need to pump water so high. Or maybe we need to regulate the flow that goes through this pump. Maybe it doesn't need so much water. We don't need so much water. And then only after that, when we have been thinking what we could do to reduce the actual load on the pump, we start thinking standard questions that all the power engineers like. Is it possible somehow to put a more energy efficient pump, rewound the pump, or what is the actual load factor of the pump to see maybe this pump is oversized and a smaller pump could be placed. Alternatively, we could have a for example, frequency regulator, electronic speed drive or controller or soft starter for the pump that could reduce the costs, the energy used during the startup and close down of the pump, or reduce the energy use when working at half capacity. And then if at the very last place, at the very last hand, we ask ourselves, okay, we have a pump, then it's oversized, it produces a lot of waste heat. What we can do with this waste heat? Is it possible, for example, to turn off a nearby radiator, so that we just use the heat from this pump, or put a regulator valve on a radiator so that we could adjust the flow that goes through the radiator depending on how much waste heat is generated at the pump. But this is kind of a ladder that we are thinking. We first think, is the work that is done by energy really needed? Could we reduce the demand in energy? And only after that we would think about more efficient motors, more efficient boilers, or renewable energy sources. First, we should look at end user, at the demand, at those pieces of equipment at our production factory that control the very demand in energy. This is the most lucrative and the most useful approach. I will jump through the slides into the distribution systems. So we have been discussing about the end user. Now let's move quickly through the distribution systems. And most of our companies, they have distribution systems, so they could do something to be more efficient with them. For example, a compressor systems. Again, when we know that the compressors are in generally very ineffective. Most of energy goes into the heat. So what is important? The first question to ask: is it possible to avoid the need in compressed air? And I've seen recently one company in Bulgaria, which believes that they're quite modern company, but they use compressors in their production process, but also for cleaning of their machineries. And it's easy. It's compressed air is very handy, but they forget that this is very expensive to clean their machineries with compressed air. And then when we were at this company, we've seen that the compressors is a real problem because they are quite old and over-dimensioned. But then we also ask them, why do you have such such a complicated and lengthy pipe work for your compressor stations? Could you reduce the unnecessary pipes or unnecessary bands that make tensions for your compressed air? Do you have any automatics that close down these compressors when not needed? And also, why do you use compressor at such a significant pressure rate? Do we really need such a pressure or not? Why? And nobody at this company could answer us. And then we try to exemplify how much would then cost to reduce the pressure level, how much would then cost to reduce number of leakages in the pipework, how much would them cost, and what would be the benefits of not having one large compressor serving all the pipelines, but maybe try to make zoning of users for compressed air. Because compressed air is very expensive, and not all the companies understand this. And before we replace our compressors, we should look what controls the demand in compressed air. Is it possible to reduce this demand? Is it possible to reduce the redundant pipework? Is it possible to make assessment and to unveil all the leakages, all the holes in this pipework, leading to misuse and loss of compressed air? Is it possible to make sure that we use really take good and cold enough air for our air compressors? Things like this. There are several publications that would advise you how to operate effectively compressor stations. But there are, before you decide to change your compressor station to a more effective one, please look at the end user. Why do we use the compressed air, and do we use it efficiently? Then some of your companies, they have cooling areas, or they cool down milk or cool down their food products. And here, most of the companies are aware that proper insulation is needed for those areas to prevent leakages of cold energy. But this is an obvious strategy. But we, as experienced professionals, we should also try to think: do we always need cold energy, or we could sometimes, for example, make sure that our cooling areas, cooling chambers are closed? Do we organize the existing fridges or cold storages effectively, so that there is a proper access to cold air to all of the products? Are we sure that we fill our fridges fully, or we just run them half empty? Things like this. So do we use cold energy effectively or efficiently? At some companies, for example, at one of the companies that we are working with, we have one problem is with drying process. This is analogous to cooling. If one of the idea is to prevent that the dried fruits would be too wet when they go to the dry process. And the same holds, for example, to cooling processes. Make sure that your food or your stuff would not be too hot, or maybe there will be some pre-cooling could be arranged before they go into the expensive cooling chamber. And make sure that when your trucks, for example, are filling this cooling chamber, they do not damage the insulation, and there are some curtains that would prevent loss of cold air during the loading operation, during the operation of forklift trucks. So everything should be done to reduce the need in cold energy, and the next step then would be to think how to reduce the leakage of cold energy, cooling energy. And the very last step would be to analyze whether the efficiency of our fridges, of cooling chambers are good enough. Most of your companies, they have boiler systems. And boiler systems, they produce thermal energy, they produce steam, and there are typical standard approaches for controlling efficiency of our boiler houses. First of all, you as experienced specialists should find out what is the actual efficiency of the boiler and compare how compares with the nominal. Maybe your boiler is working half full. This is not good for your boiler. Or maybe there are some other options to control, to make sure that the boiler is operated effectively. You could see that here this slide some standard advice on how to make sure that the boiler is operated pretty well. And I would point out that one company that uses modern boiler, but for example, they forget about deaeration of their water. They are experiencing, of course, significant problems because their water is not normalized for the use in the boiler. So by investing into deaeration station, for example, they would be able to prolong the lifetime of their boiler and thus to avoid redundant, unnecessary investments. At the same time, we as cleaner production and energy efficiency specialists, we always look into these combustion processes. We measure the secondary and primary air flows. We look at the temperature of flue gases. And there are other standard techniques to make sure that the boiler is operating efficiently and the combustion processes are complete. I think we are running out of the time, so I will not go through into more advices with regards to specific technologies, but I will also give you some hints about generic hints about what that could be applicable for our companies. We were thinking about solar panels and solar cells. There is a lot of solar in Georgia, and it's a good idea to put solar cells and solar panels, but be please aware that solar electricity photovoltaics, they produce DC voltage, and you need special converters or inverters to invert it to AC, so that could be used in your machineries, and they are quite expensive, and efficiency is not high. Whereas if you find it possible to use the solar heating, then the efficiency will jump up to 90–95%, but the price of the installations, solar panels, is much cheaper. So me as a professional auditor or professional cleaner production specialist would always think first, if I could utilize, if I need heat, then I would first of all use solar for heating, and only then would start thinking about solar power. Then our companies believe that they are efficient, but whether it's true or not true, we don't know. So it's important, and especially for energy, it's possible to find benchmarks or best reference information. Try to find such standard rates for energy consumption as per, for example, 1 ton of asphalt, as of 1 egg, as of 1 kilo of cheese, and try to establish such indicators and compare the actual situation with the benchmarks. Then you would get an immediate feeling of whether you are efficient or not. And if you don't have benchmarks, try to make graphs, and these graphs will show you whether the energy consumption is constant or not. And if it's not, then you will start immediately thinking that maybe your energy consumption is not very much related to production rates, or there are several factors that influence the energy consumption. But you also would be able maybe to establish certain norm or benchmark yourself. But it's also, you would also see if sometimes your equipment is used, or you are using much energy, and sometimes you are using too little. Maybe you have these hikes of power consumption that could be somehow shaved. And there are lots of various types of energy measuring portable equipment, which you would be willing and you have been using already. Please remember that normally this equipment is used for finding answers to specific issues, specific problems. Always try to start with general issues, and then when you arrive at certain specific problems or opportunity areas, you could do the measurements. You could measure the consumed power capacity. You could measure, for example, the temperature of flue gases. You could measure U values of your buildings. You could measure, for example, emissions from the stack or chimney in at your company. So there is some equipment, and I think this also equipment could be used for your project. Now, please talk to the Energy Efficiency Center, but the use of this equipment should be well elaborated. Only use when you have specific problem and you need specific measurements, and when you know what you want to measure. And again, please remember this letter, that first ask yourself, why do we use energy? Then could we reduce the load on equipment? Could the energy losses be minimized? Or only at the last hand, think about more recycling of energy, waste heat, or replacing, for example, a boiler with solar heaters or solar cells, or with another source of energy. First of all, think about where do we use energy, what are the end users of the energy, and whether we use this energy, this end user use energy effectively, and what could be done to reduce the energy demand at end use. This is the most profitable, the most lucrative strategy. Thank you very much. Now it's almost, the coffee break is almost over, but this was a very important subject, and I spent, I think, 35 minutes. More information is found in the slides, so you're kindly invited to go through the presentation and to learn more about this important subject. Feel free to ask questions whenever they arise. Thank you very much. And now I want to ask Konstantin and Georgi, how much time do we have till the next subject? How long would the coffee break be?
I feel that you are quite energized, but let's allocate around 15 minutes for translators to have a break. I mean, maybe 14:32.
Yeah.
I do hope that you are coming back to our virtual classroom. Please turn on your cameras, video, just for 2 minutes to take another picture after break. Maybe the others are having coffee still, but they join us. They join us. So we can continue working. Here we have one item. It's about the generation of ideas. That is the practical exercise. Mr. Dimitro, Nodar, and Konstantin will lead this process. I don't know which one will start. Kote. So maybe you take the initiative. When it comes to the practical exercise, due to the lack of time, we are not going to go in groups. And I, Dimitro, and Mr. Nodar, we will join this group. We will be just one group in order to help with this specific task.
Excuse me, Roxana. This is Irma. So it is translated, or
so we are not going to divide into groups? Yes, no groups. We will be one group and we continue working in this group. Okay, just take the initiative in your hands. And Dimitro, Konstantin, Nodar, please, let's start working. Maybe it's better just to explain first, or what to do, or how to start. Because in reality, one of us shall share the screen where we will put the content of the assignment. And of course, we have the table there, the chart which should be filled in. Also had to receive my email where you can see the video. It's about the potato chips, its preparation, its production, and we have the process, which is quite well described. It's only 5-minute video. Maybe it would be good to see that 5-minute video first and then see what type of task we have here to be fulfilled. Then we have to elaborate the diagram. Yeah. So here in the chat, I will put again this video, the link of the video, and you have 5-6 minutes just to go to that link to see the video. And let's see this short video.
მოკლედ ლინკი გაზიარებული არის.
So I've already shared the link. You can go there, see the video, and just please start in 5 minutes again.
იმედია ყველა მოახერხეთ და ნახეთ.
I do hope that you all have seen this video, and now this file is accessible in our the chat. You can find the link there, and one of the participants shall share the screen. Let's ask Luca. Luca, can you do it? Just to open and share the screen, and afterwards, of course, it is much better to have them open for yourself You also can find here the text of the requirement. Also, you can see the diagram. And then we need the root cause analysis in order to fill in the chat. As far as I know, it's in the waste oil. And yeah, it's about the waste oil specifically. And you have 5 minutes in order to learn the text.
ამოცანა რა არის? ეს არის ამოცანა მდგომარეობს სიღრმისეული მიზეზების ანალიზში და ვარიანტების მოფიქრება, გენერირება. ანუ აქცენტი უნდა გავაკეთოთ, ყურადღება უნდა გავამახვილოთ.
კარგით, ლუკა, ჩაადიდაბლა, სადაც უკვე შესავსები ცხრილები გამოჩნდება.
Let's go to the table to be filled out. First table, this is waste oil, and then it will be the waste water. So these two tables should need to be filled out. Let's come back to the table number 1. Let's start from here. And then we need to identify what sort of waste it is and how the situation can be improved. So time, let's ask Dimitro, how much time can be allowed? How much time can be allowed for this teamwork? How much time? Hello, Dimitro? Dimitri,
near 30 minutes.
40 minutes? 30 minutes? How much did you say?
30 minutes.
30, 30, okay.
ესე იგი, გვაქვს 30 წუთი დაახლოებით, ხომ? მონაწილეებს ვთხოვ, რომ მიკროფონები ჩართონ და დაიწყონ მსჯელობა. ეს არის ერთობლივი გუნდური სამუშაო, რომელიც ერთად უნდა გააკეთოთ. ასე ვთქვათ, ხმამაღლა მსჯელობა აქ თავარი მომენტია.
გაცრავად.
Sorry, but I cannot hear them. If I hear anything, then I will be translating. Otherwise, it's... No, I just hear some voices, but I cannot hear anything.
მოსაზრებები?
კარგით, როგორც ხედავთ აქ პირველ
See,
გრაფაში მაგალითად
the first
first inputs ლუკა
box,
აქ უნდა ჩაიწეროს რა მასალას რა
we should
ნიუტრიენტი
write what sort of
იყოს ზეთი ხომ რაც ერთ
substance we're talking or resource we're talking. So we're talking here about oil.
კი ბატონო წყლის ქვედა ცხრილში აქ შეიძლება უფრო
Water is in the next table.
მისი რა ქვია კარტოფილის ნაწილი
Potato
waste potatoes
parts, pieces, potato pieces.
დევ. პრინციპში ანუ ეს ორი იყო, მისი გაღწენის პროდუქტები და საკვები ზეთი.
ნარჩენი ხო?
ანუ ხო შეიძლება
Decomposition pieces. So it's not just peels, potato peels, it's just pieces of potato as well.
იდეაში ამ პროცესში გარჩევის დროს ალბათ
ისე ზეთი და იგი იქნება სხვა მეტი
ნამუშევარი ზეთი ცალსახად რჩება კი
აქ მე უბრალოდ იმაში ვერ დავინახე თვითონ. ეს გაწმენდილი მოდის უკვე ნაწილობრივ თუ ტალახი და რაღაცა.
They are washed or but first it's muddy potatoes which is washed.
და მე აი სადაც ატრიალებს დოლურაში აი ის უკვე მექანიკურად თლის
Then it's peeled automatically, machinery peels it. But the mud and the soil, it is removed with water, I think.
მოყვება თვითონ და
ქვევით მე მგონი აქ იწერება თვითონ ვინ თუ ადამიანების მხრივ თუ ვინმე არის ამ პროცესში ჩართული
I think we write here then people who is involved. The process is mostly automated, so I think the people have nothing to do with the oil, I guess. It's all automated.
შემდეგი იყო
პროცესის კონტროლი. პრინციპში რა ვიცი. პროცესის კონტროლი პრინციპში აქ ჩვენ გქონდა
Control of the process. I think it's a cycle. And the oil is removed and every 15 minutes or controlled. Maybe we go to some technological processes because we are talking about decomposition. Yeah, so can it be controlled in such a way that there is no waste residue in the oil? Maybe so the removal process or oil removal process can be controlled. Yeah, it is drying. Yeah, it's also drying. I think maybe fuel is used probably for drying. Maybe the oil can be used as a fuel. So already contaminated waste oil can be used for drying. Is it possible? We don't know what fuel is actually used for heating oil. Yes, definitely the chips are dried with air blown air, but maybe oil can be used as fuel for this process. We have a project biodiesel. I think it's not. It doesn't have direct connections with this production. Yeah, but I cannot hear him very well. It's 15 minutes right now. All is used. It's none of our business probably, but is it possible to reduce the volume of oil which is used in a single process, of frying, deep frying? Can we minimize the oil used for one process? Maybe 10 liters is needed, but they use 15 liters. So I cannot hear him. But yes, maybe oil volume can be reduced. I think that the technology was somehow established. I think they did assess and estimate how much oil was needed for single process. Maybe we'll go to product itself.
ამისგან თავისუფალი არ შეიძლება გქონდეს.
თვითონ Z-ს შეიძლება აი როგორც option-ებში.
Oil itself actually. So maybe better quality oil will be used, which is more heat resistant, temperature resistant, which can last more than 15 minutes. Yeah, there are various quality of oil. Yeah, so that it doesn't need to be replaced every 15 minutes.
ხარისხის კონტროლი, ასე ვთქვათ.
Yeah, for quality control, in other words.
Equipment-ში ეხა უკვე უშუალოდ დანადგარებზეა საუბარი აქ.
We're talking about machinery and equipment. Maybe some mesh should be established so that the potato pieces are not settled on the bottom. Yeah. So this mesh to prevent the pieces from settling on the oven bottom. Yeah, filter or mesh or something.
Technology-ში რა შეიძლება ჩაიწეროს ენერგოეფექტური?
What can we write in technology? Graph. Is it 90s? What do you think? You think is it video 97, 98? Oil is heated and yeah, maybe really this oil can be used for blowing hot air. Because really lots and lots of oil is wasted, goes down the drain. Yeah, they say that the oil is heated at 160, but what fuel is actually used? On this side. Yeah, so is it fryer replacing the oil. Can the temperature of old oil, heated oil, can it be applied? Can be used? I know that in Israel, in chips factory, actually, solar energy is used. Solar energy heats oil.
And
And they achieved really very high efficiency. Is Manana making comments? Yeah.
პროდუქტთან დაკავშირებით რა შეგვიძლია რომ ჩავწეროთ თქვა?
What can we say about product?
მე მგონი სტანდარტულებია აიგრება.
I think it's standardized size, yeah?
ანუ ხო შეიძლება თქვა იგივე
Can we write anything? Like, for example, package size reduced or some, etc., so that to waste the less volume of oil. The packages, it was said that nitrogen is used for creating vacuum, so that to preserve the seasoning, the taste of spices. No, I have no idea regarding the product. Now the second table being filled out.
კიდევ პრინციპში არის კიდევ თვითონ ნარჩენები.
Water, peels.
პროდუქტში შეიძლება დაიწეროს თვითონ კარტოფილის ხარისხის კონტროლი?
Can we write control of potato quality?
რაც არ უნდა კარგი ტექნოლოგია გააკეთო, ცუდი პროდუქტი გამოვა.
Because if the quality of potatoes is not good, whatever technology you have, the final product will not be tasty. You mean using so-called eco potatoes, or? We can write lack of quality.
ბოლო სკრიფში ხომიხდი პროდუქტის გასწრება. Quality of potatoes, როგორც პროდუქტია რა უკვე უშუალოდ კარტოფილის თვითონ პროდუქტია.
Quality of potato. Potato is also a cool product.
Quality control of potatoes.
Yeah, quality control of potatoes can be put here.
Tabla.
ამას რაც შეეხება წყალი, ეს ნაგავი რაც არის.
წყალი შემოდის თავიდან რეცხვის პროცესში, ხო?
Water is used for washing. Dirt and all things removed, and the it's peeled. And the peeled potatoes are washed again. Anew. Using maybe installing filters for recycling of water, wastewater, not to put the water down the drain. The first very dirty water cannot be used, but water which is used for washing the peeled potatoes, it can be. I think it can be recycled, it can be used. Yeah, for using this recycled wastewater for the first washing when potatoes are very muddy and very dirty. The washing of potatoes with very strong, under strong pressure. I think it's quite an old video. Now you're using different technologies for car washing, for example, and very strong pressure. I think similar technology can be used, and less water can be utilized, can be used because it's sprinkled under very high pressure. Yeah, because we see that lots of drops of water are wasted. They're splashed against the walls, and they're splashed around.
მეორეზე ვართ ხო, ლუკა, in photography positions.
ხო, არც აქ არ არის აგი.
ხო, არა.
Уважаемые коллеги,
ალბათ შეიძლებოდა ეგ ტექნოლოგიის, იგი თვითონ გარესხვის ტექნოლოგიის გაუმჯობესება.
This technology.
уважаемые коллеги, можно я дам небольшой комментарий?
Да.
Смотрите, для того, чтобы чуть-чуть сориентировать по задаче, вот я просто как бы смотрю, да, нужно постараться, вот у нас во второй колонке, в табличке, здесь мы анализируем как бы причины возникновения конкретной проблемы, да, либо отходов масла, либо сточных вод. А в колонке номер 3 нам нужно постараться подумать о тех мероприятиях, которые бы были направлены на устранение или на минимизацию причины. То есть, смотрите, если мы вот здесь говорим про входные потоки, то у нас есть входные потоки, ну, например, моющие средства там, или картофель, качество, например. И нам нужно подумать, какие мы можем предпринять меры для того, чтобы влияние входных потоков или устранило проблему, или сделало ее меньше. То есть использовать вот эту иерархию приоритетов, именно борьба с причинами. Вот в этом основная как бы наша задача. Я, возможно, ну, учитывая общее обсуждение, уловил не все, но мне кажется, что иногда мы упускаем вот этот момент. И еще один маленький комментарий относительно выше таблички по использованному маслу, то там, по-моему, вот внизу, там, где продукт, вот мы говорим о качестве входных, вот input. То есть вот это решение, которое вы предлагаете, это, как мне кажется, все-таки относится к процессу input, к верхнюю строчку. То есть контроль качества картошки, это у нас идет вверху. Это маленькое такое. А еще есть один момент. Может быть такая ситуация, что какое-то из направлений поиска причин, оно может оказаться незадействованным. Может быть, мы не можем там найти. Это тоже нормально. То есть к этому тоже нужно отнестись нормально. Все, спасибо. Если есть ко мне вопрос, я могу прокомментировать. Все, тогда продолжайте, пожалуйста. Спасибо.
ფაქტობრივად აი ეს უნდა ჩანაცვლდეს.
Actually, this should be replaced.
ანუ მეორე შვეტი პრობლემებისთვის არ გამიგდა ხოლმე შვეტი, ну
I cannot hear them now.
პრინციპში ეგ სწორადწერია პრობლემაა, ხო?
არა, მე რას გულისხმობ? მე მგონი ეს ცოტა ზევით
What I
უნდა.
mean, I think it should be put on top. Remove to the top.
კი ბატონო. მაშინ თვითონ პროდუქტის სპეციფიკაციებში, საბოლოო
In
პროდუქტი.
product specifications, I think that I couldn't get it from the film. I think that there's high probability that the chips get smashed, yeah? It's broken to pieces, so maybe these smashed pieces.
ჩიფსების გამოუშვან რა ფხვნილისგან საკუთარი პირველად იწუნდებული პროდუქციის ნარჩენისგან
ან შეფუთვა შეცვალონ მყარი შესაძლოა.
So maybe they have the different packages so that they're not smashed. No, I mean breaking and or smashing of the chips which prior to packaging. Once they get out from the oven, they are smashed. Many of them, they do not have this classic pieces, classic sized pieces. Maybe out of these smashed pieces, they produce powder, you know, separately powder, potato chip powder. Not classic chips, but powder. It's not my original idea. I stole it from someone. Oh, it was a good idea. Steal it from others. Yeah, we couldn't see what sort of losses they have in products. I'm sure that they have. I couldn't see it very well. It is cut, sliced pieces, yeah?
წისქვილი დაჭირდებათ.
So they might need some mill, grinding mill, and then some pressure to turn powder into chips again. Humidizer and pressure to produce chips from powder, or they might have two categories of chips. Like standard sized chips and smaller particles.
შეფუთვაში რაც მოხდება, უკვე მაინც გაიყიდება.
Whatever gets into a package, they are sold, you know, whether it's they're integral and undamaged or broken. As for
აი აქ process-ის მოსვლა კომენტით რო წერია, მე მგონი არასწორია იმ ხრივ რომ აქ მეწეროს
Уважаемые коллеги, посмотрите, пожалуйста, сейчас есть предложение, которое только что прозвучало, модифицировать оборудование для очистки. Но нет как бы причины, которую будет устранять. Это решение, оно направлено уже на борьбу с проблемой. Попробуйте, пожалуйста, все-таки сконцентрировать внимание на поиске причины. Это первый шаг. А второй шаг – подумать, как именно эту причину, как с ней бороться. В этом основная суть нашего задания, чтобы именно понять, как идентифицировать причину, и потом действия, которые направлены были бы на борьбу с причиной. Спасибо.
გავიჭედეთ თუ რა შეასრულა?
მე მეგონა საუბრობდნენ კიდე და მე არ მესმოდა. რა ვიცი.
ყალზე თუ კიდევ რამე გაქვს.
აი მე ვფიქრობდი აქ იქ დისპენსერი.
I thought here about the dispenser. Maybe we can put here, just put lower the dispenser. It would be better solution. Yes, it is possible to modify the dispenser. It is possible, modification of dispenser.
კიდევ პროცესის კონტროლის დროს პრინციპში
During the process control, we can see something here. Control. Yeah, what is related to the control? Maybe maintenance. For instance, the timely cleaning, the better arrangement. So maintenance issues, to improve the maintenance. Also the better planning of the control. Maybe the certain intervals or certain. Yeah, maybe it's better to put here in the impact of people's actions. Yeah. So, and what can be offered here? Maybe in the technology we put here Mr. Georgi's comment from about taking from point 2 to point 1. Okay. What else? Maybe proceeding from the specifications of the product, we can say something. We do not have the product related to water here, not a water product we have. But here we can see, but we cannot see, but maybe with regard of discharge water or maybe production of the biogas, because, you know, in the water where the potato was washed, maybe the biogas can be obtained. I don't know whether it is possible or effective. I really cannot say anything about it. It will be just a dirty water with mud, having some residue of the potato, the peeling. I know that the spirit is the possible to produce. Okay, let's do it. Let's produce. Yeah, but I don't know whether it is effective. We don't know how much the residue we have there. No, it's just an idea, Mr. Badri. Maybe we can put the idea, and if we have the enough amount, then we can also produce the spirits.
Waste potatoes.
Yeah, maybe we can do it here, put it here, where we have the waste potato.
ან პრინციპში აქ რო დავწერეთ ჩვენ ახლა რომ ამის მომსახურების პრობლემები.
So we put here that there can be some problems related to the maintenance, but it is about both of categories and not only cleaning using water, yeah? Of course, if it is treated, I mean oil, it's okay. If not, because they are replacing the oil and they are accumulating them somewhere. Yeah, it's done by themselves. It may not be automatized the process.
Process control.
So when we speak about the process control, what can be done here? In order to have less water, yeah. For instance, to use 10 liters instead of 15, just as an example. It is, by the way, related to the process of, I don't know, I cannot figure out, just having only one glance. Yeah, I have no idea what can be said here under this item. Maybe Georgi has the idea, because as I see, Nodari is busy. Frankly speaking, I'm not sure I say something reasonable, but when they receive the potato the first time, maybe it's better to dry it and then they probably clean it without water, not using washing process, because from the conveyor, they put the potato into the water. Maybe together with the hot air, using the brushes, it could be possible to clean it. I mean, as an idea, the first stage of cleaning of potato, yeah, using the brushes and hot air instead of water. Yeah. Yeah. So we, Mr. Badri, can, by the way, heat the air using the secondary oil, or the spirits maybe. Oh, we know where and how the spirits are used. You know, we know just theoretically, because practically I haven't seen people for a long time already. Most probably he means the supra, the party with the spirits, wine, etc. How much time we have? Maybe the half an hour have passed already.
Уважаемые коллеги, я думаю, сейчас у нас время уже вот-вот закончится. Пока еще минутка, возможно, есть. Попробуйте, пожалуйста, еще раз проанализировать свои опции, свои предложения, которые вы наработали. Проанализировать с точки зрения, какую причину они могут устранить. Направлены ли они на устранение причин. Посмотрите, пожалуйста, вот соотношение ваших предложений, являются ли они направленными на устранение причин, и если да, то каких конкретно причин, и как они будут влиять на причины. В этом попробуйте, пожалуйста, посмотреть через такой угол зрения.
მაგ მხრივ პრინციპში ახლა
From this point of view, we need to figure out this, which I put in the background, whether it is convenient or it is suitable or not. I cannot hear anybody. I think we have no new ideas. So this is the last version. I just was looking at this part, quite why 15 minutes? How we put here the 15 minutes? How it can help with this 15 minutes?
პრობლემა რატოა ვთქვათ?
I look at it quite skeptical. Why it is problem? They deleted that item. You know, it can be better automated. Maybe we can put here like automatization.
Вот давайте вместе попробуем. Смотрите, вот у нас есть вопрос, да, какие параметры процесса будут влиять на увеличение образования отработанного растительного масла, вот этих отходов. То есть соблюдение, может быть, не соблюдение температурного режима влиять, например. Может влиять время обжарки. То есть и, может быть, еще какие-то параметры. Мы можем записать во второй колонке как причины, приводящие к образованию именно причины, как параметры процесса. И мы можем какие-то из таких причин записать во вторую колонку. И потом подумать, какие меры предпринять для того, чтобы уменьшить влияние этих причин. Может быть, установить автоматический контроль температуры. Может быть, другие какие-то, которые бы влияли именно на причину.
ფაქტობრივად ტემპერატურული რეჟიმი აქვს განაცილება ვთქვათ.
Yeah, in fact, this is the temperature regime, or maybe distribution is not the proper one.
წნევა არ არის პროცესში?
Pressure? What about pressure? Do we have the pressure in the process as one of the items? I asked about pressure, maybe temperature and pressure control. The pressure, yeah, because you know that when they deliver water, high pressure is necessary there. It can be also we can put it also there. And what else can be?
Awesome.
და სავარაუდოდ ეს დაბინძურებული წყალიც
And
ეგრევე
most probably also this the wastewater is also discharged. Yeah, so it is polluting the environment because does it go to the sewage system or maybe it goes to the environment? Because in the process here, you can refer to the pollution because the water must be treated first and then discharged.
Oh, no wastewater from water.
Yeah, maybe, yeah, wastewater is more appropriate here.
ხო, და ამის option-ი იქნება რაც კი წერია plus
So, and the option will be what you already have written there, plus
რაიმე cleaning system და equipment-იან რაღაცა არის საჭირო მაგისთვის.
maybe some cleaning system or equipments are necessary here.
Константин, сориентируйте, пожалуйста, кто и как у нас по времени, контроль времени вот этого занятия, потому что я смотрю, что мы по графику, мне кажется, сейчас уже выходим за рамки.
კი, ნამდვილად და შეგვიძლია
Yes, exactly. And we can complete this group work now.
Да, наверное, мы уже, будем завершать. Но мне кажется, Дмитрий буквально должен немножко подытожить с Константином нашу эту групповую работу. Получилось у нас, не получилось мероприятие.
Вы знаете, Сергей, если вы не против, то мне хотелось бы услышать от кого-то из группы все-таки очень кратко их впечатление, потому что я скажу свое впечатление. Мое впечатление такое, что...
Дмитрий, давай вначале группа, давайте. Вначале группа выскажется, а потом вы свое впечатление.
Я просто думал, если наоборот, то группа сказала бы, прав ли я. Но можно и так, и так. Хорошо, Сергей. Давай так, да. Может, кто-то из группы да, сможет немножко прокомментировать впечатление, насколько это было сложно или не очень.
Понравилось, не понравилось.
Просто
удалось ли установить причинно-следственную связь, помог ли?
Да.
такой анализ, и можете ли вы, как вы думаете, сможете ли вы использовать на своих предприятиях подобный подход? Или нам вначале надо видео снять, а потом уже можно пользоваться?
Мне кажется, реакция группы была бы очень интересной нам послушать, ну, для дальнейшей работы.
Ну, я скажу, наверное.
Скажите, пожалуйста.
На каком языке только?
Ну, мне бы, конечно, на русском проще было.
Да, тогда на русском скажу. Ну, впрочем, ну, я хочу сказать, что было очень познавательно, на самом деле, очень пригодится нам это, на самом деле, при нашем анализе. Я не смогу, на самом деле, много чего сказать. Ну, этот процесс, я и думаю, что мы сможем благополучно, так сказать, использовать во время анализа наших предприятий. Такой брейнсторминг, на самом деле, был очень полезен для нас.
Пару слов. Можно я, Сергей, да?
Конечно.
Мое впечатление такое, что несмотря на то, что в группе собрались люди с большим опытом, как мне показалось, во время работы возникали некоторые сложности именно с тем, чтобы вот на каждую проблему смотреть через четкую взаимосвязь причина и устранение причины. В некотором случае идеи рождались первее, чем была идентифицирована проблема. И в некоторых случаях решения, которые появлялись в табличке, да, путем такого генерации коллективной, многие из них были направлены не на устранение проблемы, а на ликвидацию уже последствий. Но, как вот по моему наблюдению, уже к завершению нашей групповой работы, вот мое такое впечатление, возможно, я ошибаюсь, но мне показалось, что уже группа стала более четко работать и более четко вот улавливать вот эту более выражена уже была связь проблема, решение. И мне кажется, что это упражнение, я надеюсь, было полезным для наших участников. Если я где-то ошибаюсь, вы можете еще ремарочкой меня поправить. Спасибо.
Okay, maybe then we should proceed to the theoretical part of our seminar. Well, I think it was for me it was a good shake-up because we have got a practical task assignment, and I think actually the team has prepared most of the measures that I would be thinking myself. So you actually came up with an impressive list of possible corrective measures. Thank you. But now we have to go ahead. It is now, what time is it now? It is now 2:45, right? No, 4:45.
Yes.
3:45, and actually I don't have much time, so let me go. I will share with you my screen, and oh no, it was the wrong presentation. Okay. Could you see my presentation? Yeah. Is it okay?
Yes, yes.
You could see my presentation. The screen is shared.
Yes.
Okay. Let me start. Now that we have been through particular aspects of waste minimization, of energy efficiency. And let me touch upon approaches for water minimization, water efficiency, water use control. Water is water. For many of our companies, water is not very expensive, but it is still always about energy use. And we do apply the same strategies, is to try to avoid or minimize water consumption. Then if we use less water, most likely we would generate less wastewater. So then we will experience double benefits. And we try to avoid, reduce, and also finally recycle water after the treatment. But first, our task is what we could do is to prevent excessive water use before we send water to the wastewater treatment plant. And the cost of pollution of water could be much higher than the cost of using drinking water. So even if water is for free, maybe disposal or water management of wastewater would not be for free for the company. And also for us as for experienced auditors, specialists, and the redundant use of water is also a sign that something is wrong with the production management of the company. So if we see that they don't care about, the company doesn't care much about the water consumption, it means that most likely they do not care to the use of raw materials or energy either. And the water efficiency approach is the same. Once again, we look, where do we use water? Why do we use water? Do we use much or little water, efficient or not inefficient? And if we conclude that the water is used inefficiently, then why? And by answering to these questions, why, we will probably arrive at a certain measure. In our reports, in our team template, you have seen in the chapter, I think it was chapter 5, you have seen that we would fill some information about water consumption. We will try to make a water balance if possible. But what we know, that at many companies, there is only one water meter. And that is why it's not so easy to split water consumption between various users to quantify it. But using assumptions, knowing recipes, not by knowing flow rates, by doing some basic measurements, we would probably be able to account some digits, some quantities to the water use, water flows in our company. So in my working reality, assessment of water efficiency is an integral part of my work, and I hope this also would be relevant for Georgian companies. When we analyze water use, when I look, for example, at your reports, I could see that most of you call water as a water use so much. But I think it is also important for us to separate between the various flows of water. we know that the water could be used for drinking purposes. It could be used in production purposes, But then production purposes could also be split in more detail, in smaller subcategories. And typical use of water for production necessities would include process water that might require some sort of pre-treatment. It could be a makeup water for your boiler house. This could also be associated with some sort of treatment, but it could also be a cooling water that doesn't have such strong precautions with regards to water. And it could be also sanitary water, cleaning water that is used for cleaning your equipment. Different flows of water would have different requirements, different properties. And this will give us some freedom for recycling of water or reusing of water, which could not be used at one point, which has very high standards, high quality requirements, using at another point where the quality requirements are not as high, not as harsh as at this first step. This is the main clue, is that water, as soon as you have separated different flows of water, you will get the possibility to see which source of water, which flow of water could be reused and where. This is a basic trick that we, as experienced professionals, energy efficiency and resource efficiency experts are doing. Let's give you an example. For example, there is a company, brewery, that uses glass bottles in its production process. And these glass bottles, they are arriving, they need to be cleaned, washed, and then this water is then at this point it goes down the drain to the wastewater treatment plant. And then we are thinking what we could do to reduce quantity of water which is used in this washing process for washing the bottles, and then thus we could save both on water cost but also on the cost for the wastewater treatment plant. And then we split between the main categories. This is raw materials or process input. This is human factor or production practices. This is process control, equipment, status of equipment and technology. And this is the possibility for on-site reuse or recycling of water. And then we ask what could be what could induce the quantity of water that is being used for this for washing of bottles. And then we perform a brainstorm and say that okay, water is used together with some kind of cleansing agents. So what so maybe the cleansing agent is not good enough, so that we have to use a lot of water. Then we are thinking, could it be that people are responsible, that workers, employees are responsible for extensive and redundant use of water? Is it that the employees are well instructed about the use of water for washing process? Is there, for example, any internal norm or benchmark? Do they know about this benchmark? Maybe nobody knows about it. What is their attitude to if we have leakages, if water leaks down, if for example, flows are too strong and water spreads around? Do they take measures, take an action or not, just accept these practices? Do we know? Do we have a technology description that presumes at which pressure should water be added to the washing process? At which, for example, temperature should we wash our bottles? Do we? What about nozzles connected to the pressure? What about nozzles? Could we? Is it that we have wrong inject supply of water and nozzles? Could it be like that? Is it? Do we really need to clean our bottles only with water, or could it be cleaned in stages? Like first could be foam cleaning or dry cleaning, things like this. Or could we, for example, if we have generation of water, then could this water is this water so poor quality that it should go directly to the wastewater treatment plant, or could we use, for example, somewhere this partially polluted water, or maybe we could make measurements and could see that most of the water contamination generated during the first maybe 50% of the flows, but maybe the last 50% is nearly clean water. So we could this last portion of water from bottling of one bottle could be taken somewhere else. So there are lots of possible causes to the problems and lots of solution potential. But by discussing these issues and by analyzing what are the causes, we could also arrive at what are solutions. And I think what is critical here, what will distinguish an experienced expert from an unexperienced expert, with not saying about anything about their knowledge. Maybe their knowledge is equally high, but one of them, an unexperienced person, would probably look immediately at solutions, and we'll also find lots of references, lots of examples. We'll find several references and examples relevant to your company. But an experienced specialist, in turn, would first try to describe the problem, try to understand why this is a problem, and only then would generate an idea or propose an idea to mitigate this problem. Because an experienced specialist would always fight with the reason, with the cause of a problem, but not simply with the consequence of this problem. And this is what I would like you to remember. And this is, please try to apply this practice. Even if you have a stomach feeling that you could apply something for example, separation of flows, or for example, pH online measurements, things like this. Try always start with understanding what is the cause, what is the reason for the problem, and only then by understanding the reason, you would know where to purpose, where to address the identify the unveiled problems, and then your ideas would be much more tailored, much more up to the point, and much more specific and suitable. And here you see at this slide that someone who did analysis of these washing operations came up with several ideas. They have been discussing if, for example, better cleansing agent could be used, and maybe although it costs more money, but we would be able to convince our procurement department, our management, to buy something which costs more but gives much better effect in terms of water use. maybe we could better instruct our employees. It would not cost us much, but it would raise their awareness about the negative consequences of water spillages, of leakages, and they would better understand that it's, even if water is very cheap, then it's not only the cost of water itself, but it's also lots of other costs that would define our losses with regards to leakages of water. It will be energy, it could be cleaning costs, etc., etc., etc. So they would apply. They would like to apply probably also some kind of innovative measures for this washing operation. For example, dry air cleaning first, or using, for example, scratches or some other kind of instruments and tools to clean, to remove the most hard pollution on hard fat flakes or spots on the bottles. And you would probably look into the contamination in the water and to see if water from washing operations could be used for another processes. So there are lots of other things. There are lots of things. This water from washing has certain temperature, maybe it's 40 centigrades, and even if we would not find anything to recycle it, to reuse it, but maybe we could extract heating energy from this low-grade hot water, recycle it, and maybe use a heat pump or something like this for collecting this wasted energy and to put it back into the showers, for example, or for hot water. Again and again, this is cause and root analysis. We first define problem, what is a problem, then we answer a question, why is it a problem, and most likely possible there would be more than one possible alternatives. And when we find reasons, the true reason for the identified located problem, we try to address measures that would mitigate these causes. A standard approach for companies that start with water efficiency is to better measure water flows. If we cannot measure, we cannot manage. So in many companies, they would start their water saving campaigns with sub-metering of water consumption. Sub-metering of water consumption for process purposes, or for sanitary purposes, or for example, for making up water for your boiler systems. You probably would not be able to install sub-meters wherever you want at several places, but you would choose the main users, and you would probably want to install water meters at the main water users. With regards to water use, campaigns, water minimization, water efficiency campaigns always are important, and it's important that it's quite essential that our employees share your vision and be well trained on how to use water efficiently. This is very important. If we don't touch upon the processed water, then water used for sanitary, for domestic purposes, it's a lot about proper maintenance to avoid leakages, flushing toilets, and things like this. Sometimes people also forget about when they use washing machines or dishwashers. Then they forget that to use them using water saving programs, or to fill them fully, so that not to run machines, these machines being not fully loaded. We with regards to cleaning, it's another standard issue at food industry especially. And here, the last years, one could notice rapid development of water-free methods for cleaning of equipment, basically using pigging, using brushes, mops, but also not less than it's also not least using burst cleaning, where water is added at much smaller quality but at much higher pressure. They also they also they also applied recently the so-called cascade cleaning, which is a nice word, but it basically means that we make sure that we use no more water for a specific production process, for a specific piece of equipment than needed. So we basically limit the use of water for cleaning for specific operations. We establish certain norms and do not allow using more than we need to use for a specific equipment. This is the so-called cleaning in place methods. I think we can. There are different areas for water use, but once again, please remember that water and energy are very closely interrelated, and the more water we use, the more energy we use. So this is important, but in other way around, it's also there is some dependence. If we use bad quality water, then our installations that produce energy, for example, boiler houses, then they would not be able to operate as effectively as it's possible. Water needs to be cleaned, deaerated, in order for boiler to run long time and to ensure effective operation. The same may hold also to, I don't know, to compressor stations and things like this. And then the wastewater. The wastewater. When we use water, we most likely will also generate wastewater. And then please remember, during our first session, I showed you a real example with a factory in Latvia that produces jams, and they decided they could not send their wastewater because of high BOD content load to the municipal wastewater treatment plant, and they had to find a solution for this one. So the issue is that wastewater treatment is expensive, and municipal wastewater treatment plants are less and less interested to receive fatty wastewaters. That is why it is often a profitable and expedient for us to separate wastewater flow streams in order to avoid that heavily polluted wastewaters would induce the overall contamination that goes of the stream that goes down to the municipal wastewater treatment plant. So this is very important. It's important also that the wastewater treatment plants are not exposed to extra pollution from dripping of oil, from, for example, that there would be overloading of oil and other products in the vessels, and then they would be overloaded and then spill down into the rainwater system, things like this. So always try to separate clean wastewater from dirty ones, and try to control the properties of wastewaters to see if there are no hikes in certain parameters that would indicate a problem somewhere in the production process, and try to minimize, to reduce quantities of wastewater generation. This is very important, and wherever it's possible, try to do dry cleaning, try not to avoid spilling of water, try to control the quantity of water used for process and sanitary purposes. We do have sometimes need for measuring water consumption. Sometimes I do this with a bucket. Sometimes I do this with ultrasonic flow meter. It all depends. But I think at the you don't really need to make detailed measurements at the very beginning. Start with assumptions, with water balances, start with buckets. I've been working with one company that prepared a water and energy and mass balance, and they found out through the water balance that they have a leakage, significant leakage in their water supply system. And they didn't do any measurements. They just simply compared the flow meter that comes into the reading from the flow meter at the inlet to the company with the flow meter that shows how much wastewater is centralized, sent to the wastewater treatment plant. They found that these figures do not match each other. They began to look around what happens, and they found gradually within 1 or 2 months, they found a large hole in the water pipe that cost them huge money. And this they found without any sophisticated device. Later on, when they understood that they are losing water, they had a need to find exactly the place where the water is going down from the drain, from the pipe, is leaking from the pipe. That's where they use modern methods, and especially they checked the flow rates, different pipes, and then they found exactly where the hole is. This is in short about our about water efficiency issues. Please remember that water use costs money. Even if we don't pay for water itself, we pay for energy to bring this water at our company. So saving of water is always good on a micro level, but it's also very much needed on an overall macro level for the country itself. Thank you very much. This is about water efficiency. Are there any questions about this subject? I would like now to, if no questions.
არა ერთი წამით უკაცრავად ქალბატონო მე მინდა რომ თქვენ გადაუთარგმნოთ სირგეის რომ ჩვენ 1 საათით უკვე
So we are actually exceeding the time, the schedule. So we have exceeded 1 year. So maybe we postpone it for tomorrow because we have really
I'm finished. We are now 15 minutes beyond our time schedule. So I suggested that we, I think, should take a breath. And then ask ourselves questions.
Excuse me,
and if no questions, then we
it's
meet
4 o'clock now, yeah?
tomorrow.
ეხლა ერთი წუთით 15 და 55-ზე უნდა დაგვემთავრებინა.
Okay, should we stop by now and then meet each other tomorrow morning?
თვითონ გადაწყვიტოს როგორ, იმიტომ რომ ხალხსაც
Okay. Maybe we ask also our colleagues because they have also all planned their own plans.
Yeah.
So maybe we need another. Let's raise an issue. If it's okay with people, they have no special plans, then we can ask questions. Otherwise, we can postpone it for tomorrow.
ო მეც ესე ვფიქრობ, იმიტომ რომ ახლა ადამიანი რო წყვიტავს რაღაც 4-მდე, ისე იგი 4-მდე.
Because if people think that it's up to 4 o'clock, it's up to 4.
But I think let's do it tomorrow. Let's resume our work tomorrow. Now we are already 15 minutes over, right?
კარგი, ძალიან კარგი.
Okay. Let me take the opportunity to say thank you to all of you. We have had a very easy day.
We too would also like to thank you for your patience and for your very interesting presentations.
See you tomorrow.
ხვალამდე.
კარგად იყავით.